Imagine yourself staring down a massive EF3 tornado the size of a city block as it carves a path of destruction heading straight towards you. Now, what if the ground was on fire and the tornado was a rotating vortex of fire and ash with winds strong enough to wrap a steel gas pipe around an oak tree? This actually happened. They're called fire tornadoes, an extreme fire weather phenomenon as rare as a unicorn. If a unicorn showed up outside your front door, you'd probably think, what did that Starbucks barista put in my drink this morning? And if you saw another one, you'd think, where are all these unicorns coming from? In the last 3 years, there have been 6 confirmed fire tornadoes. Climate change is causing our wildfires to burn hotter and more intense than ever before, leading to these cases of extreme fire weather. But the problem is we have no idea how or where they're most likely to strike. So we need highly detailed data, only possible from observing a fire tornado up close and personal. And that is exactly what I did at the Dixie Fire on August 16, 2021. I used a mobile Doppler weather radar to capture the formation and evolution of 2 fire tornadoes as they descended down the ridgeline. So I remember, but I had to ask myself, what environmental factors present that day at the Dixie led to the rotation of those 2 smoke plumes? So I remembered what I saw. Number 1, the fire burned so hot that it forced air into the atmosphere, which condensed to form a pyrocumulonimbus cloud, which is a fancy word for saying a fire-induced thunderstorm. And number 2, the terrain was complex that could have helped increase or aid that rotation. So using the data we collected, I sliced the 2 vortices in half, revealing their dynamics, the wind speed and strength of their rotation, but also how the terrain and the pyrocumulonimbus cloud affected the rotation of these 2 smoke plumes. My results are promising, but I'm only halfway there. The next step is to use state-of-the-art modeling to simulate this event inside and out. With my project, I hope to close our knowledge gap, bringing us one day closer to when we can finally predict these unicorns of fire weather. Thank you.